All right, guys, welcome to Unit 4.3. This is going to be converting exponents in order to have the same base in order to solve for x. It's also going to be touching on the log equations that we were doing in last class. So type 1 is where we are able to convert the bases to have the same. So when thinking of exponents, we're just going to jump right into examples 1 and 2 here. If we consider the problem 2 to the power of x plus 6 is equal to 32, the base of the exponent is 2, and we need to decide if we can rewrite the number 32 using only a base of 2. Since 32 is equal to 2 to the 5th power, that should say 5th power. This means we should solve the problem by changing each side of the equation to the same base. So we have a base of 2 here to the power of x plus 6. 32 is also 2 to the 5th power. So we're going to replace 32 with 2 to the 5th power is equal to 2 to the power of x plus 6. And now that the bases are the same, the 2 and the 2, we can cancel those out. Now we just have x plus 6 is equal to 5. When solving that, we get that x is equal to -1. All right, on to the next one. We cannot use a base of 9 because 9 squared is going to be 81, so none of these are going to be able to convert in that way. But what these numbers do share is a 3. So 9 is equal to 3 squared, and 27 is equal to 3 cubed. So we're going to go ahead and replace 27 with 3 cubed. And then we're going to replace 9 with 3 squared. That 2x minus 1 needs to go in parentheses because you're going to have to distribute here. So once the bases are the same, we have 2 times 2x minus 1 is equal to 3. We distribute that 2. We get 4x minus 2 is equal to 3. We get 4x is equal to 5. And after dividing these both, we get that x is equal to 5/4. All right, type 2. If we consider the problem 5 to the power of 2x minus 3 is equal to 18, the base of the exponent is 5, and we need to decide if we can rewrite the number 18 using only a base of 5. This problem contains only logarithms. In this case, it is impossible to write the number 18 with the base of 5. So we can't change the base of 5 because there is nothing that is squared that can become 5. So it's going to stay 5 base 2x minus 13. I'm actually not going to rewrite that. And then there's nothing that is ever going to square to equal 18. So this one has to be solved like a log. All right, where the base of your exponent becomes the base of your log. It is log base 5 of 18 is equal to 2x minus 3. Log base 5 of 18 is something that we can plug into the calculator. We have worked on that a little bit, and when you do, you get 1.796 is equal to 2x minus 3, and then from here we solve just like a normal algebra problem, except we have decimals involved. Divide by 2. In this case, x would be 2.398. And that is a rounded version. All right, on to our next problem. We have 3 to the power of x plus 2 and 81 to the power of 2x minus 1. Now the 3 to the power of x plus 2 is going to stay the same. There's nothing that we can change that to, but 81 does have a 3 to the power of 4. So I'm going to replace 81 with 3 to the power of 4. And that 2x minus 1 has to go in parentheses. Now that the bases are the same, we can cancel out the 3's. So now we just have x plus 2 is equal to 4 times 2x minus 1. That becomes x plus 2 is equal to 8x minus 4. And then when solving here, we subtract the x, we move over the 4 to the other side. We get 6 is equal to 7x. We divide by 7, x is equal to 6 over 7. All right, for the next one, we have 4 to the power of x minus 1 and 8 to the power of 2x plus 3. We're going to have to change both of those to a power or a base of 2. So 4 is 2 squared, 8 is 2 cubed, so we will replace both of those. So we have 2 squared, and then we have that x minus 1 is equal to 2 cubed, and then in parentheses we have a 2x plus 3. Now that the bases are the same, we can cancel them out, and we are left with 2x minus 2 is equal to 6x plus 9. We subtract the 2x, we are left with 4x. We subtract the 9. We get negative 11, and once we divide by 4, we get x is equal to negative 11 over 4. All right, and then that is our fraction there. So we have pretty much gone over how the process is going to be completed. We're going to go ahead and move to the next page to complete a couple more examples. And again, this is a lot like last class where we're mostly just working examples, going through the steps over and over. All right, so we're on to the next one. So in this case, we have a fraction. 5 to the negative 1 power is equal to 1/5. So that is what we're going to change that base to. 25 is equal to 5 squared. So we want the bases to both be the same. So we're going to change that 1/5 to 5 to the negative 1 power. And in the parentheses, we have a negative x plus 2. And then we have 5 squared in the place of 25, and in parentheses we have 2x. From here, bases are the same. We get an x minus 2 is equal to 4x. I subtract, I get a negative 2 is equal to 3x. Divide by 3, x is equal to negative 2/3. Right, on to D. We have 1 over 100. I'm thinking we're going to have to go 10 to the negative 2 power, which is equal to 1 over 100. So we will go ahead and place that there with an x, and is equal to, so we have 10, square root of 10, so that's in 1/2. And then 6x minus 4. That square root was already there. We just moved it into an exponential form. So we're going to have to distribute that 1/2. And because the square root was in parentheses, that is why the 1/2 goes on the outside. It's going to factor. We're going to have to factor it, and it's going to end up affecting the 6x minus 4. So now bases are the same. We have a negative 2x is equal to 3x minus 2 because they were both multiplied by 1/2 here. And then after moving over the 3x, we get a negative 5x is equal to negative 2. All right, and once we divide there, we get x is equal to 2/5. All right, on to the next one. This one is one that we are not going to be able to use. 3 does not go into 36 or 35 at all, and neither does there's just nothing that they share. We can't use 9, we can't use 3. So we're going to have a log base 9 of 35 is equal to x, right? This 9 becomes the base of your log. We plug that into the calculator, which I'll go ahead and do here because I've got one right in front of me. Log base 9 of 35. X is equal to 1.618. All right, same thing on the next one. There's nothing that squares to be 15 or 30 or cubes in any way. So again, we're going to have a log base 15 of 30 is equal to x plus 3, right? I've rewritten this with the log. In the log form, it's going to be easier to solve that way. So we have a log base 15 of 30, which is going to be 1.256 is equal to x plus 3. Once I subtract that 3, we get negative 1.744 is equal to x. right, on to our next one. We have e to the power of 2x plus 1. The only thing that we can use to cancel out e is going to be ln. I don't know how to write this in order to make it sound like canceling out, but when you have an e, you can cancel it out with ln. So if I multiply both sides by ln, because whatever I do to one side, I have to do to the other, the ln and the e cancel out, so we're left with just 2x plus 1 is equal to ln of 8. Now when I plug in ln of 8, which I'm going to do on my computer right quick, I get 2.08, we'll just go ahead and round there, is equal to 2x plus 1. We subtract that 1, we get 2x is equal to 1.08. Divide by 2. Then we get that x is equal to 0.54. We're going to go ahead and leave that in decimal form. That is a-okay. All right, on to our last one. We have e to the 2x minus e to the x minus 2. This is factorable, just like a polynomial that we've seen before. In this case, an e to the 2x should be looked at as x squared. And e to the x should be looked at as x. If it is in the exponent with the x, then it's the power. All right, and then 2 will be 2. So if I were to look at this as if it were a polynomial, it would be x squared minus x minus 2 is equal to 0. And if it were 2e to the x, that would be 2x. Because the 2 is in the front, so it won't be x squared. And again, we can factor that here. It would be x minus 2, x minus plus 1 is equal to 0. And when you get to this point where I've like transformed it into a polynomial that's factorable, I'm going to go ahead and rewrite it and replace the x with e to the x as it was in the equation. Now each one of those can be solved to find a possible value of x, and it will take using ln in order to do that. So we have e to the x is equal to 2 and e to the x is equal to negative 1. Now if I multiply them both by ln, we get x is equal to ln of 2, and we get x is equal to ln of negative 1. Now if I were to plug these both into the calculator, this is approximately 0.693. And we cannot have a log of a negative, so this one is undefined. It's also called extraneous. And that is going to be all for our 4.3.